Okay, let's take a look at one last problem in our virtual review. And in this one, an elementary school student thinks that the surface area and volume of a rectangular prism will double in value if each of the dimensions of the prism is doubled in length. Explain how you would correct this misconception. So how do surface area and volume change when each of the dimensions of the prism are doubled in length? So this one probes your ability to explain, or I guess show a student a way around a common misconception about the way that length, area, and volume are related. So I would probably, to explain this, correct this misconception, I would probably show the student a simple example. So let's take a simple example and see if we can make sense of it. So suppose we took the simple example of a right rectangular prism that looked like this. Depending on the age and I guess maturity of the student, I might choose to do this with new numbers, but I'll go ahead and do it with variables since I'm speaking to you in a review. So any right rectangular prism is characterized by three variables: length, width, and height. And what we're looking at is, well, what happens when I double each of those? So if I doubled the length, of course, this would be 2L. If I double the width, this would be 2W. And if I double the height, this would be 2H. If I go ahead and look at what the surface area is here, well, the surface area has there are 6 sides, 3 of which are repeated. So we would have 2 of these front sides. Those front sides are L by H's. We'd have 2 of these back or I guess right-hand sides, and that's a width by H. And then we'd have the top and the bottom. The top, of course, is width by length. The volume, of course, is just length times width times height. Well, let's see how that compares over here. The surface area here is going to be, again, 2 of these front sides. So 2L times 2H plus 2 of these right-hand side, so that's 2W times 2H. I'm running out of room here, but you can see the pattern. I'll go ahead and put it down below. 2 of these top sides, 2L times 2W. There's some simplifying that might be nice to do here. I've got a 2 times a 2 times a 2, so it looks like it's 8LH plus 2 times 2 times 2, 8WH, 222. So HLW. And I'll go ahead and look at the volume then. The volume here would be length times width times height, so 2L times 2W times 2H, which again simplifies to 8L plus, 8LWH. And now the important job, I guess, that we've been asked to do is to sort of talk our way through how things are related when I multiply lengths times 2 in a right rectangular prism. So let's go ahead and talk about that. It looks like, if I compare surface areas first, get a highlighter out, that the surface area in the left-hand case is this algebraic expression, and the right-hand case where the lengths have been doubled is this expression, and the volume, of course, is this expression, and in the right-hand case it's that expression. And I can see that getting from here to here, I've basically taken each of these components of surface area and I've multiplied it by 4. And getting from here to here, I've taken each of these components in length, width, and height, I guess. Excuse me, I've taken this expression and I've multiplied it by 8. And this is starting to make a little bit of sense because if I rewrite these in terms of powers of 2, this would be times 2 squared, and this would be the same thing as times 2 to the third, excuse me. And so what it looks like is that when I multiply lengths by 2, my surface area is not doubled, but actually quadrupled. And my volume is not doubled at all, but actually, I guess, tripled. Excuse me, it goes up by a factor of 8. That's a 2 to the third, so I guess up by a factor of 8. So the way I would probably write this up is I would say something to the fact that I would ask the student to investigate a simple case such as a 1 times 1 by 1 cube and a 2 by 2 by 2 cube. Here we have surface area should go, well, if it's 1, 1, and 1, then I would have 2 plus 2 plus 2, or surface area would go from 6 units up to, if these are all 1s, I would have 8 plus 8 plus 8. That would be 24 units. And volume would go from, in the 1 by 1 cube, of course, 1 unit. This is squared, 1 unit cubed. Up to, let's see, volume here would be 2 times 2 times 2, or 8 units cubed. And I would say something to the fact that hopefully the student would realize that surface area goes up by, well, it looks like 4, and volume